Hello, my dear students. Welcome to the first lecture of electrostatic potential and capacitance. Today, we'll discuss the MCQ questions of electrostatic potential due to point charge, electric dipole, and system of charges. First question from the MTG fingertips book. Which of the following statement is not true? First option, electrostatic force is conservative force. Second, potential energy of charge q at a point is the work done per unit charge in bringing a charge from any point to infinity. From any point to infinity. Spring force and gravitational force are conservative force. So here in this particular case, we know that electrostatic force is a conservative force. Clear? And what is the benefit of taking conservative force or conservative force? Because we know that work done by the conservative force is path independent. Clear? Work done by the conservative force is path independent, and potential energy is generally defined for the conservative force field. Clear? So electrostatic force is a conservative force. So this is true. And potential energy of a point charge at any point at a point is the work done per unit charge in bringing the charge from infinity to any point. Clear? So work done, so potential energy is due to a point charge. Suppose if we are taking a point charge and we want to find out the potential energy at point P, which is situated at a distance r, then how will you define the potential energy of that potential energy or potential at any point? Clear? It should be generally potential. It is not potential energy. We generally calculate the potential energy due to system of two charges. Minimum two charges होना चाहिए. तो यहाँ पे हमें क्या करना पड़ेगा कि पोटेंशियल को हम कैसे डिफाइन करेंगे? तो एक टेस्ट चार्ज हमें लेना पड़ेगा, टेस्ट चार्ज क्यू नॉट, एंड इट मस्ट बी प्रेजेंट एट इन्फिनिटी इनिशियली. And the work done to bring this test charge from infinity to location P, which is situated at a distance r, that work done will be stored as potential energy in the given system of two charges. Here source charge and test charge के बीच में ये potential energy के फॉर्मेट में स्टोर होगा. तो infinity to the point. So this one will be wrong. Spring force and gravitational force are conservative forces. So here electrostatic force is a kind of conservative force. Similarly ग्रेविटेशनल फोर्स एंड स्प्रिंग फोर्स ये भी कंजर्वेटिव फोर्स है. क्यों? क्योंकि ग्रेविटेशनल फोर्स फील्ड या फिर ग्रेविटी में हम पोटेंशियल एनर्जी को डिफाइन करते हैं, एंड पोटेंशियल एनर्जी इज mgh, एंड स्प्रिंग फोर्स जो है F इज इक्वल टू -kx. तो उसके लिए भी हम यहाँ पे पोटेंशियल एनर्जी को डिफाइन करते हैं. तो पोटेंशियल एनर्जी जिसको हम बोलते हैं स्प्रिंग पोटेंशियल एनर्जी, विच इज नथिंग बट हाफ kx². क्लियर? तो जो फोर्स फील्ड में हम पोटेंशियल एनर्जी को डिफाइन कर पाएंगे उसी को हम जनरली कंजर्वेटिव फोर्स फील्ड बोलते हैं. और कंजर्वेटिव फोर्स फील्ड में वर्क डन इज पाथ इंडिपेंडेंट. वर्क डन इज पाथ independent. So here in this particular case, both option A, so that means option C is correct. So option D is the correct one here. That means it says that both A and C are correct. Moving to this question, this is statement based question. This question contains statement 1 and statement 2. Of the four choices given after the statements, choose the one that best describe the two statements. So what the statement 1 is saying is that for a charged particle moving from point P to point Q, the net work done by an electrostatic field on the particle is independent of the path connecting the point P to point Q. Clear? So here in this particular case, what it is saying is that let us consider a field, electrostatic field is present over here. Clear? And here in this particular case, the field is directed towards right, and there assume that there are 2 points. One is point P and another is point Q. Clear? So here in this particular case, what it's saying is that a charged particle moving from point P to point Q. Suppose the charged particle moves from point P to point Q via this path, or it might move in this particular path. Clear? तो ये path में जा सकते. This is path number 1. This is path number 2. Clear? So here in this particular case, what it is saying is that net work done by an electrostatic field. Net work done by an electrostatic field on the charged particle is independent of the path. It's independent of the path. That means what is the work done in moving it? Suppose if we take a test charge, clear? Test charge to from point P to point Q, then whether that work done by the field, work done, the test charge will obviously move from point P to Q, because it will, positive charges will move along the direction of field. Clear? So that means force will act upon it. Let us assume the field to be E, then force will be how much? F is equal to Q naught into E. So due to that force, it will move from point P to Q. So whether that work done is path dependent or path independent, we know that work done is equal to force into displacement. Clear? So here what we are taking this one as displacement. So it is displacement, not the distance. Clear? So that means here in this particular case, it should be independent of path. That means here independent of path does not mean that path will not be there. Path will be there, but it should be the displacement path. That means it is the shortest path. So यहाँ पे path independent का मतलब यह है कि displacement ही हमें लेना है, not distance. So that means here this particular statement is correct. Statement number 2, net work done by a conservative force on an object moving along a closed loop is 0. So work done by a conservative force. Clear? So here in this particular case, suppose this is a closed loop path, and assume that there is an object who starts its motion from A and ends its motion at A. So that means both initial and this is the initial and final. This is the initial and final. So if A is the initial and final point, then what is the work done by conservative force? Conservative force के वजह से work done कितना होगा? So force into displacement. तो displacement यहाँ पे कितना होगा? Displacement dx और displacement should be 0. Clear? तो displacement यहाँ पे कितना हो रहा है? 0 हो रहा है. तो अगर displacement 0 हो रहा है तो work done भी वहाँ पे 0 होगा. So that means statement 2 is also correct. So अभी ऑप्शन देखते हैं. Statement 1 is true, statement 2 is false. Not, it is wrong. Statement 1 is true, statement 2 is true. Statement 2 is the correct explanation of statement 1. Clear? तो यहाँ पे statement बोला जा रहा है कि statement 2 is the correct explanation of statement 1. तो इस वाले पर सेकेंड स्टेटमेंट में अगर हम देखेंगे तो यहाँ पे चार्ज के बारे में तो कुछ नहीं बताया गया है. क्लियर? या फिर फील्ड के बारे में भी मतलब इलेक्ट्रोस्टैटिक फील्ड होगा कि कौन सा फील्ड होगा उसके बारे में भी कुछ भी नहीं बताया गया. क्लियर? तो ये जो है जो यहाँ पे बोला गया है कि स्टेटमेंट 2 इज द करेक्ट एक्सप्लेनेशन ऑफ स्टेटमेंट 1. आई थिंक दैट इज रॉन्ग. क्लियर? Similarly, moving to statement option C, statement 1 is true, statement 2 is true. Yes, that is true. Statement 2 is not the correct explanation of statement 1. Yes, that will be the correct one. Clear? Here, statement 2 will not be the correct one. Why? Because in statement 1, it is talking about the charge. Clear? It is talking about the charge in a field. That means electrostatic field. Clear? And but here it is not talking about anything else. Not talking about simply it has told that conservative force. Clear? कंजर्वेटिव फोर्स ही बोला गया है और कुछ नहीं बोला गया है. तो कंजर्वेटिव फोर्स तो आपका ग्रेविटेशनल फोर्स भी हो सकता है या फिर कंजर्वेटिव फोर्स वैसे भी ले सकते हो कि वही ग्रेविटेशनल ही ले सकते हैं. क्लियर? या फिर स्प्रिंग फोर्स भी हम कंजर्वेटिव फोर्स लेते हैं तो ये कुछ भी हो सकता है यहाँ पे. क्लियर? तो क्लोज्ड पाथ में हम कौन सा ऑब्जेक्ट भी ले रहे हैं इसके बारे में भी नहीं बोला गया है. क्लियर? चार्ज पार्टिकल है या फिर कौन दूसरा ऑब्जेक्ट, तो इस कुछ नहीं बोला गया. तो नो कनेक्शन एंड ऑप्शन डी तो नहीं होगा. सो फाइनली हियर ऑप्शन सी विल बी द करेक्ट वन. नेक्स्ट थर्ड क्वेश्चन, 1 volt. 1 volt, how will you define this 1 volt? Clear? So 1 volt, that means it is taken as the unit of potential. And how will we define the potential at any given point? Potential due to, we define the potential due to a charge. Clear? So potential due to a charge at any location at a distance r. How do we define at point P? How do we define that one? Potential is nothing but K Q divided by R. Clear? Or it is generally this potential definition wise. How do we define that one? It is the Warden in moving a unit positive charge. Warden in moving a unit positive charge from infinity to the given location. From infinity to the given location. तो यहाँ पे अगर हम एक टेस्ट चार्ज को लेंगे तो उसको जब हम इन्फिनिटी से उस लोकेशन तक लाएंगे तो जितना वार करना पड़ेगा, दैट वार डन डिवाइडेड बाय टेस्ट चार्ज विल गिव अस द पोटेंशियल. So here in this particular case, if we just see the unit, naturally the unit of potential is volt, but यहाँ पे जो पोटेंशियल का जो 1 वोल्ट है वो और किसके साथ इक्विवेलेंट है. क्लियर? So whether it is Newton per second, Newton per coulomb, Joule per coulomb or Joule per second. So it is Warden, the unit of Warden is Joule and unit of charge is coulomb. So it should be Joule per coulomb. Moving to question number 4, the Warden in bringing a unit positive charge from infinite distance to a point at distance x from a positive charge q is W. So here what it is saying is that Warden bring a unit positive charge from infinite distance to a point at a distance x from a positive charge. So there is one charge already there in the field in the space, that is q, that is the source charge. Clear? And we'll bring a unit positive charge. We'll bring a unit positive charge which is present at infinity to a distance x from the positive charge q. That means that's a location P which is present over here, and that location is at a distance x from the given positive charge, and we'll bring this unit positive charge from infinity to the given location point P. Then the potential at that point is, what is the potential at that point? So then we know that potential will be, just now we have defined that potential is Warden in moving the charge divided by magnitude of the test charge. Clear? तो यहाँ पे क्या बोला गया, यूनिट पॉजिटिव चार्ज, तो उसका मैग्नीट्यूड कितना होगा, 1 ही होगा. That means magnitude of that 1, if it is 1, then this potential will be nothing but W. Clear? Potential at that point will be how much? At that point will be simply W. So option B will be the correct one. So W upon X or WQ upon X, that will be wrong. W into Q also wrong. Next we'll go through the topic MCQ questions of potential due to a point charge. Here in this particular case, potential due to a charge is given, or potential, or find out the potential at point due to a charge. Charge is given 5 into 10 to the minus 7 coulomb located 10 centimeter away from it. So we know that potential due to a point charge will be defined as 1 upon 4 pi epsilon naught q by r. Clear? So if it is the case, we know then charge is given 5 into 10 to the minus 7 and distance is given 10 centimeter. Clear? So finally the value of 1 upon 4 pi epsilon naught is 9. It is 9 into 10 to the power 9. The value of q is 5 into 10 to the power minus 7 all divided by the distance is 10 centimeter converted into meter, so 10 into 10 to the power minus 2 meter. So this particular value, if we do the calculations, it will be 45 into 45 into 10 to the 9 plus 2, or it will be 10 to the minus 10 to the minus 1. If it goes up, then 10 to the 10, so 10 minus 7, so 10 to the power 3. So it will be 4.5 into 10 to the power 4. Here 4.5 into 10 to the power 4. So finally here in this particular we'll check the options. Options are given 3.5 into 10 to the power 4 volt, and here 3.5 into 10 to the power 4 10 to the 5 volt, 3.5 10 to the 5, then 10 to the 4 wrong, then 4.5 into 10 to the 4, yes it is this much volt, and 4.5, okay, here option it should be 10 to the 5, here it is 10 to the power 5. Clear? So this is wrong. So finally option C will be the correct one. Okay, next what is saying in question number 5, the warden is bringing a charge 4 into 10 to the minus 9 coulomb from infinity to that point is, what is the warden? Clear? So here in this particular case, already there is a charge of 10 to the minus 7 coulomb. Clear? So here what the thing is saying is that already there is a charge. What is the magnitude of the charge? It is 5 into 10 to the power minus 7 coulomb, and at a distance of 10 centimeter, from it, there is a point where we just calculated, just now we calculated the potential to be 4.5 into 10 to the power 4 volt. It is 4.5 into 10 to the power 4 volt here. And right now what it is saying is that another charge of 4 into 10 to the minus 9 coulomb, which is initially present at infinity. So at infinity, suppose this is infinity, right now there is a charge 4 into 10 to the power minus 9 coulomb, and we want to bring it from infinity to this particular location. Clear? Then is saying what is the work done. So we know that the potential, or you can say this work done, तो एट दिस पर्टिकुलर लोकेशन, और अभी इस लोकेशन पर पोटेंशियल हमें मालूम है. मान लो कि अभी ये जो केस है, तो इसमें मान लो कि ये वाला जो पार्ट है, दिस पार्ट इज नॉट देयर. क्लियर? ये जो हम मान लेते हैं कि ये अभी हमें कुछ नहीं मालूम है. क्लियर? कौन सा चार्ज है, क्या चार्ज है, लेकिन हमें अभी क्या है, बस इतना ही बताया गया है कि एक लोकेशन, मतलब एक स्पेस है, स्पेस में एक लोकेशन पी है, जिस पी पॉइंट पर पोटेंशियल हमारा कितना है, 4.5 इंटू 10 टू द पावर 4. क्लियर? तो उस लोकेशन पर अगर एक चार्ज है जो कि अभी इंफिनिटी में प्रेजेंट है, उसको अगर हम इस लोकेशन पर ला के रखेंगे तो वार कितनी. क्लियर? तो वर्क डन जो है वो उसको हम कैसे डिफाइन करेंगे, पोटेंशियल के थ्रू. क्लियर? अच्छा, तो इस वाले पर्टिकुलर केस में हमें ये मालूम है कि पोटेंशियल डिफरेंस जो है डेल्टा वी, दैट वो कैसे हम डिफाइन करेंगे, वार्डन पर यूनिट चार्ज. क्लियर? तो वार्डन पर यूनिट चार्ज मतलब इस वाले पर्टिकुलर केस में पोटेंशियल डिफरेंस बिटवीन द पॉइंट पी एंड इन्फिनिटी, इन दोनों के बीच में. तो वार्डन भी क्या होगा, वार्डन टू मूव द चार्ज फ्रॉम इन्फिनिटी टू द पॉइंट पी. सो फ्रॉम इन्फिनिटी तो पॉइंट पी, तो पी एंड इन्फिनिटी के बीच में जो वार्डन होगा, दैट डिवाइडेड बाय द गिवन चार्ज. क्लियर? तो यहाँ पे टेस्ट चार्ज हम ले रहे थे जब डिफाइन कर रहे थे, तो यहाँ पे क्या होगा, वार्डन बिटवीन पी एंड इन्फिनिटी डिवाइडेड बाय द गिवन चार्ज. क्लियर? So that means Warden between P and infinity should be equal to the given charge into potential difference between P and infinity. Clear? So here in this particular case, तो अभी हमें यहाँ पे ध्यान में रखना है कि इनिशियल लोकेशन कहाँ पे और फाइनल लोकेशन कहाँ पे. तो इनिशियली द चार्ज was at infinity, and finally after some time it will reach at point P. That means potential difference, that Q will be equal to Vp माइनस वी इन्फिनिटी. ये हमें पोटेंशियल डिफरेंस में देगा, पोटेंशियल डिफरेंस. क्लियर? सो दैट मीन्स बट पोटेंशियल एट इन्फिनिटी ड्यू टू द गिवन चार्ज, जो पहले से हम चार्ज ले रहे थे उसके वजह से इन्फिनिटी पे पोटेंशियल कितना होगा, 0 होगा. दैट मीन्स इट शुड बी सिंपली क्यू इंटू पोटेंशियल एट पी. तो डायरेक्टली हम पोटेंशियल का कॉन्सेप्ट यहाँ पे ले सकते हैं. तो पोटेंशियल हम डिफाइन करते हैं V इज इक्वल टू डब्ल्यू अपॉन क्यू. तो उससे वार्डन कितना होगा, वार्डन टू मूव और प्लेस ए चार्ज इन ए गिवन पोटेंशियल रीजन. So that will be simply Q into V. Here, Warden to place a given charge in a given potential region will be simply Q into V. So then Warden will be how much? So Q is given 4 into 10 to the power minus 9, जो given अभी है. Clear? सोर्स हमें नहीं लेना है, सोर्स का चार्ज हमें नहीं लेना है. एंड पोटेंशियल एट द लोकेशन पर पोटेंशियल कितना है अभी, जस्ट वी गॉट 4.5 इंटू 10 टू द पावर 4. सो अभी ये वैल्यू कितना हमें मिलेगा, so that will be 0, 16, 18. So 18 into 10 to the power minus 5. Clear? So 18 into, we'll get 18 into 10 to the power minus 5. So 18 into 10 to the power minus 5. So here options are 2.4, this will be wrong. So 1 point into 10 to the power minus 4. तो ओके 8, तो यहाँ पे ये वाला ऑप्शन बी विल बी द करेक्ट वन। तो इसको हम अगर थोड़ा बहुत डेसिमल को इधर ले आएंगे तो ये वैल्यू कितना हो जाएगा, इट विल बी 1.8 इंटू, इट इज 10 टू द पावर माइनस 5, नॉट, so 10 to the power minus much. So here in this particular case, option B will be the correct one. Okay, here in question number 7, the electric field intensity at point P due to point charge Q kept at point Q is 24 Newton per Coulomb. Okay, so here what it is saying is that electric field intensity at point P due to a point charge Q kept at point Q. Okay, so there are 2 points. Let this be point Q and let this be point P. At point Q, a small charge Q is kept, and at point P, due to the charge, the field is how much? Electric field over here is 24 Newton per Coulomb. And electric potential at point P due to the same charge is, electric potential at the same point is 12 Joule per Coulomb. The order of magnitude of charge Q is. Okay, so what is the magnitude of this charge Q, or order? That means it is asking order of magnitude. That means in the powers of 10. So the relationship between field and potential, we know that E, magnitude of electric field, is nothing but E by R. Generally, the relationship between E and V is that E equal to minus E by dr. That means electric field is in the direction of decreasing potential, or it is in the negative gradient of potential. So magnitude wise relationship between E and V is E equal to V by R in general sense. Then R will be equal to, so R will be equal to how much? V upon E. So that means the value of V is 12 upon E is 24, so it will be 0.5. So R is coming to be 0.5 meter. So here in this part, that means if R is 0.5, then what is the value of Q? So we know that V is 12 Joule per Coulomb, and the value of V, we know that KQ by R. So that means here, from here, that we can say that KQ by R equal to 12. So KQ equal to 12 into R. So that implies 12 to 0.5. So that will be 6. Then Q will be equal to 6 upon 9 into 10 to the power 9. So it will be 2 by 3 into power minus. So this is the magnitude of charge. Then what will the order of this charge? Order of this charge will be 10 to the power minus 9 Coulomb. So order will be 10 to the power minus 9 Coulomb. So option D will be the correct one. Okay, so here in question number 8, what it is saying is that 2 points A and B are located in diametrically opposite directions of a point charge of plus 2 microcoulomb at a distance of 2 meter and 1 meter respectively from it. Okay, so if we draw the figure over here, so here what it is saying, there is a 2 microcoulomb charge. There is a 2 microcoulomb charge which is located at the center. Okay, fine. So here in this particular case, assume that at the center there is a 2 microcoulomb charge, and there are 2 points A and B located diametrically opposite directions of a point charge of 2 microcoulomb at distance 2 meters. So that means A is located at a distance of 2 meter and B is located at a distance of 1 meter. If we'll take this particular point to be A, then if it is at a distance of 1 and 2, so here it will be B. The potential difference between A and B. So potential difference between A and B is delta V. It is asking to find out. So between A and B, that means VA minus VB. Clear? So how will you calculate the potential at A and potential at B? So potential at A, that means we are going to calculate at a distance of 2 meter, and here it is 1 meter. Location B. So potential at A, it is nothing but KQ divided by RA minus potential at B will be KQ divided by RB. It is a scalar quantity, so simply we'll write it without any direction. So K is how much? K is 9 into 10 to the power 9 into Q is 2 microcoulombs, so 2 into 10 to the power minus 6 whole divided by distance is 2 meter. This particular distance, this means here this particular distance is 2 meter, and here over here this is 1 meter. Clear? So finally this RA that we take 2 meters, so that means it will be 2 minus K is 9 into 10 to the power 9. So here if we put the values directly, 9 into 10 to the power 9, Q is 2 into 10 to the power minus 6 all divided by RB is 1. Here if we take common, so it will be 9, or it will be directly if I will be writing over here. So 9 into 2, 18, so 10 to the 9, 10 to the minus 6, so 10 to the 3. So 18 into 10 to the power 3. If we take it common, so 1 by 2 minus 1. Here, so 18 into 10 to the power 3 minus 1 by 2. So here it will be minus 9 into 10 to the power 3 volt. So finally what we are getting, the potential difference is minus 9 into 10 to the power 3 volt. So option C will be the correct one. Moving to question number 9, a charge Q is placed at the origin O. So here at this particular point, a charge Q is present of x y axis as shown in figure. The work done in taking a charge Q, a charge capital Q, which is initially present over here, from A to B along the straight line AB. So work done is moving a charge Q from A to B. So here in this particular case, the work done in moving the charge from A to B will be nothing but charge which is taken capital Q from A to B. That means it will be Q into delta V. Clear? So here it's Q into delta V. That means the final potential will be at B minus initial potential will be at A. That means potential difference between A and B. So Q into VB. VB, that means potential at this particular location, which is situated at a distance of B from plus Q. So it will be KQ divided by B minus potential at A, which is situated at a distance of A from plus Q, is KQ divided by A. So taking KQ common, so KQQ 1 by B minus 1 by A. So it will be KQQ, so LCM will be AB, or you can say BA. So B, if it goes, so it will be A minus. So finally in this particular case, take the correct one. So given Q by 4 pi epsilon naught A minus by A. So this is the work done while moving the charge from A. So QQ by 4 pi epsilon naught A minus B by A. First is the correct one. Rest of the B minus A by A. B here B by A square minus 1 by B. So this all these rest others will be wrong. So option A will be the correct one. In question number 10, as per the diagram, a point charge plus Q is placed at the origin O. A point charge plus Q is present at the origin. Work done in taking another point charge minus Q from the point A. So initially a negative charge minus Q is present at A. and that A is located at a distance small a from the origin to another point B. B is present at a distance of A. That means both A and B are equidistant from the charge along the straight line AB. So here we want to move the negative charge from A to B. Then what will be the work done? So we know that work done while moving the charge from A to B will be nothing but the given charge, which is minus Q into potential difference between the given locations. That means here work done is work done is path independent, as work done is path independent. So that means here in this particular case, so we are taking we are taking the potential difference. Clear? So we are taking the potential difference. We are taking the potential difference between the given locations. So we are taking the potential difference between the given locations. So here in this particular case, so minus Q into delta V. Delta V is nothing but it will be VB minus VA. That means we are moving the charge from A to B. So A is the initial location, B is the final location. So potential at B minus potential at A. So minus Q and potential at B will be KQ divided by A, and potential at A will be KQ divided by A. So both are equal. So that means here potential difference is 0. So that means work done will be 0. Clear? So work done will be how much? Work done will be 0 over here. As both the locations are equidistant from the charge, that means it will form a equipotential. That means these two locations, if we draw a sphere kind of thing, or you can say circle, that means these 2 points will come out over a equipotential region. Clear? So that means both will be having same potential. So option A will be the correct one. Okay, so here in question number 11, electric field and potential of an electric dipole vary with distance r. Okay, so electric field and electric potential. Field and potential, how does it vary with distance r? So we know that if we take a dipole system means a negative charge and a equal amount of positive charge when they are separated by some distance, let it be. So here if we take the midpoint of the dipole, so from the midpoint of the dipole, if we take a distance r, that means at location P, suppose if we want to calculate the electric field as well as potential. Clear? So then electric field due to the dipole, we know that electric field is coming out to be simply 2AP by RQ. Clear? So electric field, that means here in this particular case, electric field is inversely proportional to the cube of R. Clear? For the case of dipole. Similarly, potential at point P, that means both are that means here we are calculating the electric field and potential at the axial point. Clear? So it will be simply Kp by R square. Clear? So that means here in this particular case, potential is inversely proportional to the square of distance. Clear? So potential is Kp by R square, and electric field is 2 Kp by Rq. That means here in this particular case, we must remember that electric field is inversely proportional to cube of R, and potential is inversely proportional to square of R. So we'll check that one. First is electric field and after that potential. So first must be cube. That means cube and square. Square, cube, square. Okay. So option D will be the correct one. Clear? And similarly, suppose if we want to find out these are the electric field at axial point and potential at axial point. Suppose if we want to measure the electric field at equatorial point, electric field at equatorial point will be minus Kp by Rq, and potential at the equatorial point is 0. Clear? So in general sense, at any point, clear, at any point, how does this electric field and potential vary? So these are the specific locations. In general sense, it varies inversely. Electric field varies inversely with cube of r, and potential varies inversely with square of r. Clear? So option D will be the correct one. Next, in question number 12, the ratio of electric potential due to an electric dipole at the end of position to that in the broadside on position for the same distance from it. Okay, so dipole system, one a negative charge, another must be a positive charge, separated by distance 2a, and the distance is very small, and at the end on position. End on position means axial position. End on position. End on position indicates axial position. And broadside on position. Broadside on position indicates equatorial position. Position. So here in this particular case, we are calculating the potential at the end position. So the potential at the axial or end on position will be nothing but simply Kp by, if distance of separation is taken as r from the midpoint of the dipole, then it will be Kp by r square. ये कितना होगा? Kp by r square. Clear? और इक्वेटोरियल पॉइंट उतना ही डिस्टेंस, मान लो कि ये डिस्टेंस जो r लिया गया उतना ही डिस्टेंस हम मान लो कि यहाँ पे ले जाए. क्लियर? सो दैट मीन्स दिस पर्टिकुलर डिस्टेंस इज टेकन एज r. तो ये वाला पोजीशन पर हमारा पोटेंशियल कितना होगा? इक्वेटोरियल पोजीशन पर पोटेंशियल हमारा जनरल कितना होता है? 0 होता है. क्लियर? तो ये उसका लॉन्ग डेरिवेशन है. लॉन्ग डेरिवेशन बुक में प्रोवाइड किया गया है. तो यहाँ पे हमें ये बोला गया है कि इन दोनों का रेशियो कितना होगा? रेशियो ऑफ इलेक्ट्रिक पोटेंशियल. सो रेशियो विल बी हाउ मच? दैट मीन्स वी ए अपॉन वी ई. सो फाइनली वी ए अपॉन वी ई. That means end on ratio of electric potential at the end on position to the broadside on position will be Kp by r square by 0. So something by 0 will be how much? Infinity. Clear? So that means the ratio will comes out to be infinity. तो ये रेशियो कितना होगा? इन्फिनिटी होगा. So it will be option A. Okay, so moving to question number 13. Which of the following is not true? For a point charge, electrostatic potential varies h1 by r. So we know that for point charge, the potential is v equal to 1 upon 4 pi epsilon naught q by r. So that means this potential is inversely related to r. So varies h1 by r. That means this statement is correct. For a dipole, the potential depends on magnitude of position vector. For a डाइपोल के लिए पोटेंशियल जो है वो पोजीशन वेक्टर के ऊपर डिपेंड करता है और डाइपोल मोमेंट के ऊपर भी डिपेंड करता है. ओके फाइन. सो हियर इन दिस पर्टिकुलर केस पोटेंशियल ड्यू टू ए डाइपोल. सो पोटेंशियल ड्यू टू ए डाइपोल एट एनी जनरल पॉइंट वी नो दैट v इज इक्वल टू k p cos theta divided by r square. So here in this particular case, this is the potential due to a dipole at any general point. That means at axial point. For axial point, then theta will be 0 degree. That means this is for theta is equal to take 0 for axial point. And for equatorial point, theta will be taken to be 90 degree. Equatorial point. So here in this particular case, if theta is equal to 0 degree, then v equal to kp by r square, and here it will be 0. So potential at the equatorial point is 0 and potential at the axial point is 0. So here this potential in general case, it depends upon the position vector here r, and the dipole moment vector, it depends. That means this option is also correct. The potential of an electric dipole varies as 1 by r at large distance. Clear? At very large distance, what it is saying is that potential of a dipole varies as 1 by r, but here what we are getting potential at very large distance we are getting to be is inversely related to r square. It's inversely related to r squares, but it is saying 1 by r. That means this option is incorrect. For a point charge, electrostatic field varies as 1 by r square. We know that the electric field due to a point charge is simply kq by r square. So that statement is also correct. So which of the following is not true? So option C will be the option for this particular question. Okay, here in question number 14, the distance between H plus and Cl minus ion in HCl molecule is 1.38. We know that HCl molecule is an dipole, forms a dipole system. Here both H plus and Cl minus will be separated by some distance, and that is 1.38 angstrom. So assume that this is H plus and here it is Cl minus, and both are separated by a distance of 1.38 angstrom. So H plus is having a charge of positive charge of 1.6 into 10 to the power minus 19 coulomb, and the Cl minus is having a charge of minus 1.6 into 10 to the power minus 19 coulomb. तो एक ही पॉजिटिव चार्ज है, तो मतलब वो उसका वैल्यू कितना होगा 1.6 इंटू, दैट मीन्स यहाँ डेफिशिएंसी ऑफ 1 इलेक्ट्रॉन. एक इलेक्ट्रॉन का डेफिशिएंसी है, तो एक इलेक्ट्रॉन का डेफिशिएंसी है मतलब एक इलेक्ट्रॉन का चार्ज जितना है उतना यहाँ पे नहीं है. क्लियर. तो उतना अमाउंट का पॉजिटिव चार्ज यहाँ पे जनरेट हुआ है. तो और यहाँ पे क्लोरीन में क्या हो रहा है, एक एक्सेस इलेक्ट्रॉन है, तो एक्सेस इलेक्ट्रॉन का चार्ज कितना है यहाँ पे माइनस 1.6 इंटू 10 माइनस 9. So the potential due to this dipole at a distance of 10 angstrom. Potential due to this dipole at a distance of 10 angstrom. That means we will find out the potential at a distance of 10 angstrom on the axis of the dipole. On the axis of the dipole, that means it will be taken from the midpoint of the dipole and at the axial point. Axial point 10 angstrom. So here what are the given informations? The value of 2a is given. That means dipole length, that is 1.38 angstrom. So it is 1.38 into 10 to the power minus 10 meter, and the value of r is given over here 10 angstrom, that is 10 into 10 to the power minus 10 meter. So it will be 10 to the power minus 9 meter. Clear. So what is the potential at the axial point? So we know that potential due to the dipole at the axial point is kp by r square. Here, so here what will be the dipole moment? Dipole moment, we know that kq into 2a all divided by r square. So potential is k is 9 into 10 to the power 9. Charge, either you have to take either of the charge you can take magnitude wise. So it will be 1.6 into 10 to the power minus 19 into 2a is 1.38 into 10 to the power minus 10 all divided by r square. That means 10 to the power minus 9 whole square. Okay. So if we do the calculation, so how much we'll be getting? So it will be 9 into 1.6 into 1.38 whole into 10 to the power 9 minus 19 minus 10, and here it is 10 to the power 9, its power is 2, that means 10 to the power minus 18, and if it goes up it will be plus 18. Clear. So finally this order will become minus 19 plus 18 will be minus 1, 9 minus 1, 9 minus 1, that is 8. So 8 minus 10. So it will be 10 to the power minus 2. So it will be 10 to the power minus 2. So 9 into 1.6 into 1.3. So this calculation multiplication will tell us. So here 1.6 into 9. So 16 into 9 give us 144, that means it will be 14.4 to 1.38. we can take it approximately 1.4. हम थोड़ा बढ़ा रहे हैं, clear? So finally, and this particular value will be 10 to the power minus 2. 14, we know that for the square of 14 square is 190. So that means it is 14.4 into 1.38, that will be more than 196. Clear? More than, it will be 196. That means इसमें 1.4 है, clear? तो 1.4 है और ये 14.4 है, तो approximately will take it to be assume to be will get 20 around, clear? It should be 19, it should be 19.6. अगर यहाँ पे 14 and 1.4 होता तो ये 19.6 होता है, क्लियर? तो ये 14.4 है और ये 1.4, जो कि 1.38 को हम अप्रोक्सीमेटली मतलब 1.4 अगर एज्यूम करें तो ये 20 के आसपास मान लो कि हमें मिलेगा। तो 20 इंटू 10 टू द पावर माइनस 2, so that means 0. Clear? So how much will get the potential? Potential will comes out to be 0.2 volt. Clear? So we'll check the option. It is 2.1, 1.8, 0.2 and 1. Obviously these values are not possible to clear. These values will not be possible, and 1.2 is also not possible because the potential is coming out to be very small. So option C will be the correct one. Moving to question number 15. 4 points A, B, C and D are set at equal distance from the center of a dipole as shown in the figure. The magnitude of electrostatic potential at VA, VB, VC and VD, that means at all the location A, B, C, D, would satisfy the following relation. कौन सा relation यहाँ पे ये satisfy? तो यहाँ पे ये जो केस है, इसको ये जो फिगर है इसको हम थोड़ा बहुत रीड्रॉ कर लेते हैं। तो यहाँ पे दिया गया क्या है, इसको अगर हम थोड़ा ड्रॉ करेंगे इससे, तो ये हमारा this is A B. Assume that this is A B. We'll take one here. Location, this is A B A C A. This is A and C. यहाँ पे हमारा C A C and upper section it will be, here you will get D. So along AC the dipole is present. What is the dipole? The dipole is plus Q towards A and minus Q towards B. Okay, so this is the dipole, and what it is saying is that this is the dipole. So here in this particular case potential at A. So as this is the dipole, then what is the relationship of potential at all the location A, B, C and D? So we know that B and D both are present at the equatorial line of the dipole. Clear? At the equatorial line of the dipole, that means here potential will be 0 and potential at D is also 0. Potential at C, if it is situated at a distance that it will be x, then potential at C will be equal to KQ upon or the potential KP will be K, as we are taking a dipole, so the Kp upon x square. Similarly, potential at A will be also Kp upon x square. So that means here in this particular case what will be getting, potential at A equal to potential at C and potential at B equal to potential at D, and that is 0. So ये दोनों same है, and here as we are getting some values Kp upon x square, that means the values of these two is greater than 0. So we'll have to check that one. So option A is incorrect, as that means it is showing that potential of all at all the points is not equal. And here also VA is greater than VB, VA greater than VB, okay, and greater than or equal to VD greater than VC. Clear? Greater than, here it is not greater than, here it is equal to, there is no greater than sign here. There is no greater than sign. Here it is equal sign. Okay, here it is greater than sign is there, but no equal sign. Okay, so right now all the options are, I think it is correct. Okay, so here in this particular case we'll have to choose that one. That means option B, VA greater than VB. Yes, that is correct. VA greater than VB. VA is KP upon X square. VB is 0. And that is VB equal to VD. VB is equal to VD, that is equal to 0. And VD is greater than VC. That is wrong. Clear? VD is 0. And how can it becomes greater than VC? Option C, VA equal to VC. That is correct. And that is greater than VB equal to VD. That is greater than VB equal to VD. Yes, option C, correct answer. And here we don't have to check the option D further. Why? Because VB equal to VD. VB equal to VD, that is correct. And it is VD is greater than VA. VD is greater than VA. How can it be greater than VA? Because VD is 0 and VA is KP upon X square. So this is wrong. And VA equal to VC. And that is not satisfying over here. So option D is also wrong. So option C is the correct one. Now we'll discuss the MCQ questions of potential due to a system of charges. So here in this particular case, the first question is, figure shows the field lines of a positive point charge. There is a positive point charge and its field lines are shown. What done by the field in moving a small positive charge from Q to P? Okay, so assume that assume the small charge is equal to Q. तो मान लो कि ये जो स्मॉल चार्ज है उसको हम Q से P तक लाएंगे. विल मूव द चार्ज फ्रॉम Q to P. So here in this during this case the work done will be 0, negative, positive and data insufficient. So work done क्या हम निकाल सकते हैं? Okay. Initially assume that the charge is at Q and finally it will be at P. Clear? So that means जब charge Q at Q, then what will be the potential energy of the system? Potential energy at Q will be how much? It will be simply Q into potential at means Q into potential at Q, and similarly at P, what will the potential energy of the system? It will be simply Q into potential at P. Here, so as we know from there, what we know that potential at P is greater than potential at Q, and यहाँ पे हमें ये मालूम है कि पॉजिटिव चार्ज दैट मीन्स पॉजिटिव चार्ज से जितना पास होगा पॉइंट तो पोटेंशियल ज़्यादा होगा. एज वी मूव अवे फ्रॉम द चार्ज पोटेंशियल डिक्रीजेस. क्लियर? बिकॉज इट इज़ इनवर्सली रिलेटेड विद डिस्टेंस. तो अगर ये इनवर्सली रिलेटेड है और पोटेंशियल एट पी इज ग्रेटर देन पोटेंशियल एट क्यू, देन व्हाट इज द वर्क डन इन मूविंग द चार्ज फ्रॉम क्यू टू पी? वर्क डन बाय एक्सटर्नल एजेंट. एक्चुअली यहाँ पे फील्ड के अगेंस्ट में हम चार्ज को ले रहे हैं और वो भी पॉजिटिव चार्ज को. तो वर्क डन किसके द्वारा किससे होना चाहिए? एक्सटर्नल एजेंट से वर्क डन होना चाहिए. देन वर्क डन विल बी नथिंग बट चेंज इन पोटेंशियल एनर्जी ऑफ द सिस्टम. चेंज इन पोटेंशियल एनर्जी ऑफ द सिस्टम इज नथिंग बट UP minus UQ. Final potential energy is at P and initial potential energy is at Q. So this is the change in potential energy of the system. So that means UP is Q into VP minus Q into VQ. So here Q into VP minus VQ. So that means this will be positive as VP is greater than VQ. But here it is asking what is the work done by the field. What is the work done by the field? Field के वजह से कितना होगा? So work done by the field will be negative of change in potential energy of the system. Clear? So negative of change in potential energy means negative of U final minus U initial. That means its general formula is U initial minus U final. So u initial, that means u at q minus u at p. Initially the charge is located at q and finally it will be at p. So that means what you can write, it will be q into vq minus vp. So as vq is less than vp, that means this particular value will be negative. यहाँ पे ये वैल्यू क्या होगा, नेगेटिव हुआ. सो वर्क डन बाय द फील्ड विल बी नेगेटिव. तो फील्ड की वजह से जो वर्क होगा वो यहाँ पे क्या होगा, नेगेटिव होगा. एग्जाम्पल इसका एक मैं यहाँ पे एक आपको लेके देता हूँ. फॉर एग्जाम्पल सपोज वी आर टेकिंग ए पॉजिटिव चार्ज ऑफ लेट इट बी 2 nano coulomb. Clear? And we will take two locations over here. One is at this particular point, which is situated at a distance of 1 meter, and another location we will take which is situated at a distance of 2 meter from the charge. Then potential at let it be p and q. Potential at p due to that charge will be k q divided by r. So k is 9 into 10 to the power 9 into charge is 2 into 10 to the power minus 9 all divided by distance first at point p means 1. So it will be 18 volt. Similarly potential at q will be how much? Potential at q will be same k q divided by r distance, let it be rb. Here it is ra. So it will be 9 into 10 to the power 9 into 2 into 10 to the power minus 9 divided by 2. So it will be how much? Simply 9 volt. That means over at point p potential is coming to be 18 volt and at point q the potential is coming to be 9 volt. तो ग्रेजुअली पोटेंशियल यहाँ पे डिक्रीज हो रहा है. तो मान लो कि हम वही चार्ज को ले रहे हैं क्यू चार्ज को. जब हम क्यू चार्ज को क्यू पॉइंट पे रखेंगे, स्मॉल क्यू चार्ज, when the small q charge will be at point q, then potential energy will be how much? 9q. जब ये q चार्ज को हम पॉइंट p पे रखेंगे तो पोटेंशियल एनर्जी कितना होगा? It will be 18q because q into potential at that location, that will give us the potential energy. Clear? So potential energy at q is coming out to be 9q and potential energy at p is coming out to be 18q. So then work done by the field. तो work done by the field is what? Negative of change in potential energy of the system. और हम चार्ज को q से p तक ले रहे हैं. वी आर मूविंग द चार्ज फ्रॉम q टू p. तो उसका मतलब है वर्क डन बाय द फील्ड विल बी u q minus u p. Initial potential energy minus final potential energy. So uq is 9q minus 18q. That will give us minus 9q. So that is coming out to be negative. So here in this particular case, always remember that work done by the, ये जो फॉर्मूला है ये हमें याद रखना है कि work done by the field is negative of change in potential energy of the system, but work done by the external agent is directly equal to negative of change in potential energy of the system. Clear? So ये यहाँ पे ऑप्शन सी will be the correct one. In question number 17, the figure shows the field lines of a point negative charge. Negative charge यहाँ पे उसका field lines यहाँ पे शो किया गया है. In going from B to A, जब हम B से A तक जाएंगे तो the kinetic energy of small negative charge will, तो एक B से A तक जब हम जा रहे हैं B to A, then what about the kinetic energy of negative charge? एक नेगेटिव चार्ज को हम B से A लेंगे तो उसका kinetic energy क्या वहाँ पे इंक्रीज होगा, डिक्रीज होगा, कांस्टेंट रहेगा या फिर डाटा इनसे. तो इस वाले पर्टिकुलर केस में तो जब हम नेगेटिव चार्ज को बी से ए तक ले रहे हैं, नेगेटिव चार्ज, दैट मीन्स वी आर मूविंग अगेंस्ट द फील्ड. फर्स्ट इज अगेंस्ट, मूविंग अगेंस्ट द फील्ड, not moving against the field, moving against the force, moving against the repulsive force, moving against the repulsive force. Why we are moving against the repulsive force? Because it is already a negative charge and we are moving another negative charge towards a negative charge. That means like charges repel each other. क्लियर? तो इसीलिए वहां पे क्या हो रहा है, रिपल्सिव फोर्स आ रहा है. तो रिपल्सिव फोर्स के अगेंस्ट में जब हम जा रहे हैं तो वहाँ पे क्या होगा, ग्रेजुअली ये जो चार्ज है इसका स्पीड वहाँ पे क्या होगा, डिक्रीज होगा। क्लियर। फोर्स के डायरेक्शन में अगर मान लो कि यहाँ पे अगर हम पॉजिटिव चार्ज लेते हैं तो ऑटोमेटिकली इट स्पीड विल इंक्रीज। क्लियर। क्योंकि जैसे जैसे ये जो चार्ज है, मतलब ये जो एक्सटर्नल चार्ज है, जब ये सोर्स चार्ज की तरफ जाएगा तो फील्ड क्या होगा, फील्ड ग्रेजुअली इंक्रीज होगा। क्लियर। फील्ड ग्रेजुअली इंक्रीज होगा तो पॉजिटिव चार्ज होता है तो उसके ऊपर अट्रैक्टिव फोर्स बढ़ता। अट्रैक्टिव फोर्स बढ़ता है तो वहाँ पे क्या होगा, काइनेटिक एनर्जी उसका ग्रेजुअली इंक्रीज होता है। बट यहाँ पे नेगेटिव चार्ज ले रहे हैं तो नेगेटिव चार्ज को जब हम नेगेटिव के पास लेंगे तो रिपल्सिव फोर्स ज़्यादा स्ट्रॉन्ग होगा। दैट मीन्स वहाँ पे ऐसा भी चांस आ सकता है कि वी कैन नॉट मूव दिस नेगेटिव चार्ज, एक्सटर्नल नेगेटिव चार्ज टुवर्ड्स दिस सोर्स चार्ज। तो इसीलिए यहाँ पे यह है कि इसका जो काइनेटिक एनर्जी है, दैट मीन्स योर वेलोसिटी विल डिक्रीज। तो वेलोसिटी डिक्रीज होगा तो वहाँ पे काइनेटिक एनर्जी क्या होगा, तो ऑप्शन बी विल बी द करेक्ट वन। Moving to question number 18. Here, two tiny spheres carrying charges 1.8 microcoulomb and 2.8 microcoulomb are located 40 centimeter apart. Two tiny spheres, that means assume that there are two tiny spheres will take, these spheres are located at a distance of 40 centimeter apart. That means distance of separations are generally taken from the center of the given spheres. So this is 40 centimeter. Okay, the potential at the midpoint of the line joining the two charges is, okay, assume that these are two charges and it is the line which joins them. Clear. Then this will be the midpoint of the system, and if it is the midpoint of the system, then what is the potential at this particular point? So midpoint means this will 20 centimeter and it is also 20 centimeter, and the charges are 1.8 microcoulomb and this is 2.8 microcoulomb. So then first of all find out the individual potential and then add them, because potential is a scalar quantity. So here we can directly add them. So potential at the midpoint let it be P. So potential at point P will be nothing but potential due to 1.8 microcoulomb charge plus potential due to 2.8 microcoulomb charge. So here in this particular case, what we'll be doing, potential at P due to the 1 microcoulomb charge will be kq, as this is a point charge, so it will be kq divided by distance of separation, that is let it be r, because both are same. So kq by r plus kq prime divided by r. So here k and r we can take it outside, k by r, so q plus q prime. So k is 9 into 10 to the power 9. Distance is 20 centimeter, means 20 into 10 to the power minus 2. Q is 1.8 microcoulomb, that means 1.8 into 10 to the power minus 6 plus 2.8 into 10 to the power minus 6. So here in this particular case, 9 into 10 to the power 9, 10 to the power 6, if we take it outside, 10 to the power minus 6 all divided by 2 into 10 to the power minus 1. So it will be 1.8 plus 2.8. So 1.8 plus 2.8. So it will be approximately 6, 16, so 2, 3, 4. So 4.6. So finally the value will be, potential at P will be 9. So 10 to the 9 minus 6 is it is 10 to the 3, and here it will be 10 to the 4. So 9 into 10 to the power 4 divided by 2 into 4.6. So it will be 2.3. So 9 is 27. So 2 remaining. So it will be 20.7 into 10 to the power 4. So potential at P will comes out to be 20.7 into 10 to the power 4. 3.8 into 10 to the power 4 is wrong. 2.1 into 10 to the power 5. 2.1 into 10 to the power 5, we'll check it. So if we write 2.07 into 10 to the power 4 volt, 2 point, okay, ये 10⁵, it is 10⁵, क्लियर। तो इट विल बी 2.1, क्योंकि डेसिमल को अगर हम थोड़ा लेफ्ट लाएंगे तो पावर्स इंक्रीज होता है। तो ये बी ऑप्शन सही आ रहा है, सी इनकरेक्ट, एंड डी 3.6 तो बहुत ज़्यादा है यहाँ पे, ये नहीं होगा। सो इट विल बी अप्रोक्सीमेटली दिस वन, दैट मीन्स पोटेंशियल एट बी पी विल बी 2.1 into 10⁵ volt will be the correct answer. Next, in the same question, it has what it's saying is that potential at a point 20 centimeter from the midpoint of the line joining the two charges in a plane normal to the line passing through the midpoint is, okay. So it is saying is that it is asking out as means equatorial position. ये तो डाइपोल नहीं है, बट जनरली व्हाट इज सेइंग, ये इसका मिड पॉइंट से ऊपर की तरफ हमें लेना है, क्लियर। So here in this particular case, let us draw the figure once again. So these are two tiny spheres having charges, and distance they are separated by 40 centimeter, and this is the midpoint, and from the midpoint we'll take a distance 20 centimeter. 20 centimeter हमें यहाँ पे लेना है। तो ये जो पॉइंट है, दिस पॉइंट विच इज सिचुएटेड एट अ डिस्टेंस ऑफ 20 सेंटीमीटर फ्रॉम द मिड पॉइंट ऑफ द डाइपोल, तो ये भी 20 होगा और ये भी आपका 20 होगा, 20 cm 20 cm इच। देन व्हाट इज आस्किंग, फाइंड द पोटेंशियल यहाँ पे हमें इस पॉइंट पर यहाँ पे निकालना है, इस पॉइंट पर, क्लियर। एज पोटेंशियल इज अ स्केलर क्वांटिटी, तो यहाँ पे कोई वेक्टर का चक्कर नहीं रहेगा, नो नीड टू गो थ्रू द वेक्टर रिजोल्यूशन, जैसे हम फील्ड के केस में निकाल रहे थे। सो डायरेक्टली विल फाइंड आउट द पोटेंशियल। So potential due to this 1.8 microcoulomb charge and this is 2.8 microcoulomb charge। तो 1.8 से इसका दूरी है, मान लो कि 1.8 से ये जो पॉइंट पी का डिस्टेंस हम ले लेते हैं यहाँ पे ये, और इससे डिस्टेंस भी उतना ही होगा, क्लियर, बिकॉज इट इज एन आइडियल सिस्टम। तो इस वाले केस में डिस्टेंस कितना होगा, 20, सो इट विल बी 20 स्क्वायर प्लस 20 स्क्वायर, सो 400 प्लस 400, दिस मीन्स 800, सो अंडर रूट 800, so under root 800, so that value will be 2 into 400, so that means 20 root 2, so its value will be 20 root 2 cm, and this is also 20 root 2 cm. So that means potential directly we are doing potential at P will be potential due to 1.8 microcoulomb charge plus potential due to 2.8 microcoulomb charge. So potential at due to 1.8 at a distance of 20 root 2 centimeter will be K into Q divided by distance is same R, so here it will be K Q prime divided by R. So we can take K by R common, so Q plus Q prime. So let this charge be Q and this charge be Q prime. So here in this particular case 9 into 10 to the power 9, distance is 20 root 2 centimeter, means 20 root 2 into 10 to the power minus 2 meter. And here in particular case Q, what is the value of Q? Q is 1.8 into 10 to the power minus 6 plus 2.8 into 10 to the power minus 6. So finally we can take 10 to the power minus 6 outside, so 9 into 10 to the power 9 into 10 to the power minus 6 all divided by, here it will be 2 root 2 into 10 to the power minus 1. So 18 plus 1.8 plus 2.8 is 4.6. So it will be 2.3. So finally here what we'll get, simply we know that 9 into 10 to the 9 into 2.3, that will come out to be the value of previous one. Previously हमें जो मिल रहा था ये वही वाला केस है, क्लियर। तो इसमें जो वैल्यू हमें मिला था वो वैल्यू कितना था, दैट वैल्यू वाज 2.1, 2.07 यहाँ पे मिला था, जो कि 2.1 हम ले रहे थे। तो ये वैल्यू को अगर हम यहाँ पे लेंगे तो इट विल बी 2 2.1 into 10 to the power 5 divided by root 2. Clear? So 2.1 into 10 to the power 5 divided by root 2. So if we calculate this value, so that calculation, so here we can write 2.1 divided by 1.414, so let it be 1.4 into 10 to the power 5, so it will be 21 by 14 into 10 to the power 5. So if we divide 21 by 14, so 14 ones are 14, so it will be 7, so decimal, so it will be 71.5, so it will be 1.5 into 10 to the power 5. So net potential at point P will be 1.5 into 10 to the power 5 volt. So 1.5 into 10 to the power 5, so option A is the correct one, so rest others should be wrong. Next, here in question number 20, four equal charges Q each are placed at four corners of a square of side A. Okay, there is a square whose side is A. Okay, side is A, and Q charges are present at the corners of the square. Okay, fine. What done in carrying a charge minus Q from its center to infinity? Okay, center यहाँ पे मान लो, तो center to infinity. So let us join the corners first. So we'll get the center. तो सेंटर पे एक नेगेटिव चार्ज माइनस क्यू यहाँ पे प्रेजेंट है, तो उसको हमें कहाँ तक लेना है? उसको हमें इन्फिनिटी तक लेना है. विल नीड टू टेक दैट वन टू इन्फिनिटी. हमें इन्फिनिटी तक यहाँ पे लेना है. क्लियर? तो मतलब नेगेटिव चार्ज को सेंटर से इन्फिनिटी तक वार्डन लेने से जितना वार करना पड़ेगा उतना ही वार्डन हमें इन्फिनिटी से सेंटर तक लाने में करना पड़ेगा. क्लियर? तो उसका उल्टा वाला केस अगर हम लेंगे, व्हाट इज द वार्डन टू मूव द चार्ज फ्रॉम इन्फिनिटी टू द गिवन सेंटर ऑफ द सिस्टम. तो उसके लिए हमें क्या करना पड़ेगा? तो पहले तो हम यहाँ पे एक काम करते हैं कि हमें ये तो मालूम है कि ये पूरा का पूरा सिस्टम जो है वो पॉजिटिव चार्ज वाला सिस्टम. क्लियर? तो उसके वजह से हमें पोटेंशियल इस सेंटर पर यहाँ पे पहले निकाल लेना है. क्लियर? तो जब हम वार्डन निकालेंगे तो पोटेंशियल एनर्जी का डिफरेंस ले जाएंगे, दैट विल गिव अस द वार्डन. तो पहले तो हम सेंटर पर पोटेंशियल एट द सेंटर विल बी हाउ मच? So potential at the center will be the potential due to the all individual charges, and all individual charges are situated at a distance of what? तो ये डायगोनल, ये साइड अगर ए हुआ तो ये डायगोनल कितना होगा? √2a, और इसका आधा हमें लेना है, तो ये कितना होगा? इट विल बी √2a डिवाइडेड बाई 2, सो इट विल बी a बाई √2. और एक डिस्टेंस यहाँ पे कितना होगा? a बाई √2, a बाई √2, a बाई √2. ऑल द चार्जेस आर सिचुएटेड एट ए डिस्टेंस ऑफ a by √2 from the center, or center is located at a distance of a by √2 from each and individual charges. So that means potential at the center due to four charges, all the four charges will be equal to 4 into potential due to single चार्ज के वजह से पोटेंशियल पहले निकालो और 4 के साथ मल्टीप्लाई कर दो, देन दैट विल गिव अस द पोटेंशियल ड्यू टू ऑल द 4 चार्जेस, क्योंकि पोटेंशियल एक स्केलर क्वांटिटी है. तो फाइनली पोटेंशियल इक्वल टू 4 इंटू के सिंगल चार्ज के वजह से कितना होगा? के क्यू डिवाइडेड बाय डिस्टेंस, जो कि आर हम लेंगे फॉर्मूला वाइज. सो हियर इन दिस पर्टिकुलर केस चार्जेस आर क्यू इच, so 4 into k into q is same, and the distance is a by, तो ये हमें मिला कितना? 4√2 kq by a. क्लियर? तो पोटेंशियल एट द सेंटर इज कमिंग आउट टू 4√2 kq by a. ओके, सो एंड सिमिलरली अगर ये हमें सेंटर पर पोटेंशियल यहाँ पे मिला, तो फिर सेंटर पर जब हम नेगेटिव चार्ज को रखेंगे तो उसका एनर्जी कितना होगा? क्लियर? तो जब उस नेगेटिव चार्ज को हम यहाँ पे मान लो कि सेंटर पर रख रहे हैं, देन पोटेंशियल एनर्जी ऑफ द नेगेटिव चार्ज सिस्टम व्हेन इट इज केप्ट एट द सेंटर, तो ये कितना होगा माइनस क्यू इंटू पोटेंशियल एट द सेंटर। तो माइनस क्यू इंटू पोटेंशियल एट द सेंटर इज 4√2 के क्यू बाई आर, क्लियर। तो इट विल बी 4 माइनस 4√2 के क्यू स्क्वायर बाई आर। तो हियर दिस इज द, ये जो है ये हमें क्या मिला, दिस इज द potential energy, potential energy potential energy of the system, potential energy of the system when minus q charge is at the center, जब माइनस क्यू चार्ज आपका यहाँ पे सेंटर पे होगा। अच्छा तो अच्छा, जब हम उस माइनस क्यू चार्ज को इन्फिनिटी में ले जाएंगे, मान लो कि इन्फिनिटी पे जब होगा, तो उसमें उस नेगेटिव चार्ज का पोटेंशियल एनर्जी कितना होगा, तो जीरो होगा, क्लियर। क्योंकि पोटेंशियल एनर्जी एट, दैट मीन्स पोटेंशियल एट इन्फिनिटी, potential at infinity due to the system will be potential at infinity will be zero. That means this is the potential due to the system at infinity. why it is zero? because अगर हम यहाँ पे ये देखेंगे कि मान लो कि ये स्क्वायर को हम थोड़ा साइड व्यू से देखेंगे, तो ये एक स्क्वायर है, तो इसमें कुछ चार्जेस यहाँ पे प्रेजेंट है, और हम इन्फिनिटी मान लो कि यहीं पे कहीं पे, दैट मीन्स द होल्स, ये जो इंडिविजुअल चार्जेस आर लोकेटेड एट डिस्टेंस ऑफ इन्फिनिटी, क्लियर। और यू कैन से इन्फिनिटी फ्रॉम द गिवन पॉइंट, और दिस इन्फिनिटी इज लोकेटेड एट डिस्टेंस इनफाइनाइट। हर एक चार्ज मतलब सिस्टम से इन्फिनिटी का डिस्टेंस इन्फिनिटी होगा, क्लियर। तो अगर सिस्टम का डिस्टेंस इन्फिनिटी हुआ तो हर एक चार्ज का डिस्टेंस भी इन्फिनिटी होगा, क्लियर। तो इसीलिए यहाँ पे पोटेंशियल एट इन्फिनिटी ड्यू टू द होल सिस्टम विल टेकन टू बी जीरो, क्लियर। तो अगर पोटेंशियल जीरो हुआ तो पोटेंशियल एनर्जी, यहाँ पे पोटेंशियल एनर्जी एट इन्फिनिटी वो भी क्या होगा, जीरो होगा, क्लियर। एंड लेट मी कंसिडर द पोटेंशियल एनर्जी ऑफ नेगेटिव चार्ज एट द सेंटर। तो इसको हम मान लो कि थोड़ा बहुत करेक्शन कर लेंगे, तो ये जो है हमारा ये क्या होगा, ये सेंटर पर, क्लियर। दिस इज द पोटेंशियल एनर्जी एट द सेंटर पर हमें इतना मिला, क्लियर। अच्छा, तो फाइनली अभी हम चार्ज को सेंटर से इन्फिनिटी तक ले रहे हैं, तो सेंटर से जब हम इन्फिनिटी तक लेंगे तो यहाँ पे वर्क कौन करेगा, क्लियर। तो नेगेटिव चार्ज इज प्रेजेंट इनसाइड द सिस्टम, तो यहाँ पे अट्रैक्टिव फोर्स है, और वी आर मूविंग अगेंस्ट द मतलब फोर्स ऑफ अट्रैक्शन के अगेंस्ट में जा रहे, देन वर्क विल बी डन बाय द एक्सटर्नल एजेंट। तो यहाँ पे कौन काम करेगा, एक्सटर्नल एजेंट यहाँ पे करेगा, देन मीन्स वर्क डन बाय द एक्सटर्नल एजेंट विल बी नथिंग बट चेंज इन पोटेंशियल एनर्जी ऑफ द सिस्टम। तो चेंज इन पोटेंशियल एनर्जी मतलब हम सी से सेंटर से इन्फिनिटी तक ला रहे हैं, दैट मीन्स यू इन्फिनिटी माइनस यू सेंटर। इन्फिनिटी पे जीरो है और सेंटर पर हमें कितना मिला पोटेंशियल एनर्जी हमें मिला माइनस 4√2 के क्यू स्क्वायर बाय आर, clear. So here if we put this value, that means we will be getting 4√2 k q square by r. But here in this particular case, remember that the value we will substitute over here, k is 1/4 pi epsilon naught, and r will substitute a by √2। ये वैल्यू हमें सब्सिट्यूट करना पड़ेगा बिकॉज ऑप्शंस आर गिवन लाइक दैट, क्लियर। तो ये सब वैल्यूज को जब हम सब्सिट्यूट करेंगे तो हमें यहाँ पे कितना मिलेगा, वर्क डन विल बी 4√2 k is 1/4 pi epsilon, so 4 pi epsilon naught q square divided by r is a by √2, क्लियर। तो यहाँ पे ये वैल्यूज को जब हम सब्स्टिट्यूट करेंगे तो ये ये पहले से ही सब्स्टिट्यूटेड है ना यहाँ पे, अच्छा थोड़ा बहुत गलत हो गया है, यहाँ पे ए होगा, क्लियर। पोटेंशियल एट सी कितना होगा, ये ए होगा, पहले से ही सब्स्टिट्यूट किया गया है ना, तो ये ए होगा, ये ए, सो फाइनली ये ए आएगा। तो नो नीड टू सब्स्टिट्यूट द वैल्यू वन सेकेंड, तो आर का वैल्यू मतलब ये हम फिर दोबारा नहीं लेंगे, तो ये ए होगा, this will be a. Clear? So finally no need to substitute this value once again. So यहाँ पे ये सब हमारा a होगा, ये a, तो ये √2 फिर दोबारा हमें सब्स्टिट्यूट करना नहीं पड़ेगा. सो 4 × k² बाई a, 4 k का वैल्यू यहाँ पे सब्स्टिट्यूट किया गया है. सो 1/4 सो 4 गॉट कैंसिल. सो इट विल बी √2 q² अपॉन एप्सिलॉन नॉट पाई a. So it will be √2 q² upon epsilon naught pi a. So √2 q² upon epsilon naught और pi epsilon naught a. So that means option B will be the correct one. So थोड़ा बहुत यहाँ पे ध्यान में रखना है. So गड़बड़ी में यहाँ पे इसको हमें क्या लेना है, ये a है, ऑलरेडी a ले चुके हैं. So due to some mistakes we have taken r. तो ये a कर लेना है इसको. ठीक है, ऑप्शन इसीलिए तो ये बेनिफिट है कि ऑप्शन दिया गया है तो उसी से हमें पता चल जा रहा है. क्लियर? Okay, so finally option B will be the correct one. Next, question number 21. Here in this question, a cube of side x has a charge q at its each of vertices. The potential due to this charge array at the center of the cube is. Okay, so here what it's saying is that let us consider a cube first. Draw a cube first. Then only we can understand what the actual system is. This is a cube whose side is side x. So finally here okay, this is what we are getting, and assume that the center is over here. यहाँ पे कहीं पे सेंटर हमारा है. क्लियर? तो एंड सेकेंड थिंग इज दैट एट द वर्टेक्स चार्ज q आर प्रेजेंट. q कितना चार्ज होगा, 8. तो यहाँ पे सभी में क्या है, q चार्ज यहाँ पे प्रेजेंट है. तो सेंटर पर पोटेंशियल कितना होगा, तो हाउ विल यू कैलकुलेट दिस वन. तो इस पहले पर्टिकुलर केस में हमें ये सब डिस्टेंस, इंडिविजुअल डिस्टेंस यहाँ पे कैलकुलेट करना है. तो ये जो सेंटर का लोकेशन हमें कैसे यहाँ पे निकालना है. तो मान लो कि ये जो सिस्टम है यहाँ पे कोई भी एक चार्ज से अगर हम ये डिस्टेंस निकालना है कितना होगा, तो ये एक आइडियल सिस्टम है. तो आइडियल सिस्टम में है मतलब बाकी सब चार्जेस से ये सेंटर का जो डिस्टेंस होगा उतना ही होगा. तो मान लो कि ये लेफ्ट साइड वाला सरफेस लेंगे, तो ये वाला केस इसको हम थोड़ा बहुत समझ लेते हैं कि ये कैसा है. तो इसमें अगर हम देखेंगे ये वाला केस में, तो साइड इसका कितना है, हर एक साइड यहाँ पे x है. तो ये अगर x हुआ तो ये जो डायगोनल यहाँ पे फॉर्मेशन हो रहा है, तो ये कितना होगा, दैट डायगोनल विल बी √2x. क्लियर? तो ये डायगोनल हमें कितना मिला है, √2x. अच्छा, तो डायगोनल अगर √2x मिल रहा है तो ये जो डिस्टेंस है यहाँ से यहाँ तक का जो डिस्टेंस, ये कितना होगा, √2x/2. ये कितना होगा, √2x/2. क्लियर? तो ये अगर तो मतलब x/√2, ये वैल्यू हमें कितना मिला गया, x/√2. क्लियर? अच्छा, यहाँ से अगर हम देखेंगे तो इस वाले सेंटर पोजीशन से इसका डिस्टेंस कितना होगा. क्लियर? तो ये बराबर हमें मिल जाएगा कितना, इट विल बी ऑब्वियसली हाउ मच विल गेट इट टू बी समथिंग लाइक x/2. अगर ये पूरा का पूरा डिस्टेंस यहाँ पे x है, ये x है, तो इसका आधा यहाँ पे कितना होगा, x/2. क्लियर? सो देन व्हाट विल बी दिस पर्टिकुलर डिस्टेंस. तो ये जो डिस्टेंस है ये क्या अभी हमें मिल सकता है, यस वी कैन गेट दैट वन. क्लियर? तो ये डिस्टेंस कितना होगा, सो दैट डिस्टेंस विल बी इक्वल टू x/√2 का स्क्वायर प्लस x/2 का स्क्वायर एंड रूट ऑफ दैट वन. तो इसको अगर हम कैलकुलेशन करेंगे तो इसका रिजल्ट कितना मिलेगा, सो इट विल बी x²/2 प्लस x²/4 और उसका रूट. क्लियर? तो हियर इन दिस पर्टिकुलर केस इफ वी टेक एलसीएम, so 4 with 2x² plus x², of that one, so it will be 3x² upon 4 root. So it will be root 3x by 2. Clear? So here that means what this we are getting, this distance we are getting root 3x by 2. तो उसका मतलब है हम डायरेक्टली यहाँ पे ये बोल सकते हैं कि ये जो सेंटर है, सेंटर विल बी लोकेटेड फ्रॉम दिस चार्ज। सेंटर, ये जो यहाँ पे ये वाला जो चार्ज है, इससे सेंटर का दूरी कितना होगा, ये होगा रूट 3x/2। और इस चार्ज से ये सेंटर का दूरी कितना होगा, रूट 3x/2। हर एक चार्ज से सेंटर का दूरी कितना होगा, रूट 3x/2। हर एक चार्ज से सेंटर का दूरी यहाँ पे रूट 3x/2। हर एक चार्ज से सेंटर का दूरी यहाँ पे रूट 3x/2। क्लियर? ये भी, ये वाला जो है इससे भी रूट 3x/2 ही मिलेगा। क्लियर? सो दैट मीन्स the net potential at this particular location, so net potential at the center will be 8 into potential due to the single charge, 8 into potential due to the single charge. So 8 into potential due to a single charge is kq divided by distance is how much, distance is root 3x by 2. Clear? So how much we'll be getting, so here in this particular case 8, so 8 means 2 if it goes, so it will be 16 kq divided by root x. So potential at the center will be 16 kq by root 3x, but we have to put the values of k over here. So potential at the center will be 16 q divided by 4 pi epsilon naught root 3x. So 4 just 16, so it will be 4q divided by root 3 pi epsilon naught x. 4q divided by root 3 pi epsilon naught x. So 4q divided by root 3 pi epsilon naught x. So here दिस इज रॉन्ग, रूट 3 रहना चाहिए। रूट 3 यहाँ पे इतना तक ही रहेगा। क्लियर? रूट 3 ये वाला रूट थोड़ा गलत है, तो रूट 3 यहाँ पे इतना तक ही रहेगा। क्लियर? उससे ये वाला तक नहीं रहेगा। क्लियर? सो ऑप्शन बी। तो हियर इन दिस पर्टिकुलर केस यहाँ पे रूट 3 पाई एप्सिलॉन नॉट एक्स है, बट यहाँ पे 2q है, सो दिस विल बी रॉन्ग। ये 3q है और ये 4q है, तो ऑप्शन ए या बी होगा। तो यहाँ पे रूट 3 नहीं है और यहाँ पे रूट 3 पूरा पूरा सब में दे दिया है, तो यहाँ पे रूट 3 यहाँ पे इतना तक है, रूट 3 पाई एप्सिलॉन नॉट एक्स। हो ऑप्शन बी विल बी द करेक्ट वन। Okay, in question number 22, what is saying? A hexagon of side 8 centimeter has a charge 4 microcoulomb at each of its vertices. Hexagon means it has 6 sides. The potential at the center of the hexagon is. So first of all, draw the hexagon first, hexagonal system. So here all sides are equal. And there will be 6 sides. Okay, assume that this is a regular hexagon. Clear? That means all sides are equal, and what is asking, it is asking to find out the potential at the center. तो center पर यहाँ पे potential हमें निकालना है. That means if we just join these lines from the vertices, so if it is a regular hexagon, so here in this particular case, in a regular hexagon, what you can say, this will form equilateral triangles. Clear? यहाँ पे ये क्या होगा, ये साइड और ये साइड, ये तीनों इक्वल होगा. Clear? So in a regular hexagon, the triangles formed inside are all equilateral triangles. Clear? जितना भी ट्राइंगल यहाँ पे फॉर्मेशन हो रहा है, ये सब साइड्स यहाँ पे क्या होगा, इक्वल होगा. तो अगर ये साइड्स यहाँ पे इक्वल है तो मतलब यहाँ पे साइड जो 8 सेंटीमीटर दिया गया, तो ये 8 हुआ, तो ये भी 8 होगा, ये भी 8 होगा। क्लियर? तो ये हमारा सेंटर है। और यहाँ पे ये बोला गया है कि चार्ज जो प्रेजेंट है, 4 माइक्रोकुलम का चार्ज यहाँ पे प्रेजेंट है कॉर्नर्स में। सो 4 माइक्रोकुलम ओवर हियर, इट इज ऑल्सो 4 माइक्रोकुलम, 4 माइक्रोकुलम, 4 माइक्रोकुलम, 4 माइक्रोकुलम। नो नीड टू राइट। जब हम न्यूमेरिकल सॉल्व करते हैं तो एग्जामिनेशन पर्पज के केस में आपको ये सब इतना ज़्यादा लिखने का जरूरत नहीं है, डायरेक्टली आप इसको सॉल्व कर सकते हो। बट यहाँ पे थोड़ा समझाने के लिए हमें यहाँ पे बनाना पड़ रहा है। तो इस वाले केस में तो पोटेंशियल कितना होगा, 6 चार्जेस है, देन पोटेंशियल एट द सेंटर विल बी 6 इंटू पोटेंशियल ड्यू टू द सिंगल चार्ज। सिंगल चार्ज की वजह से पहले पोटेंशियल निकाल लो और उसको 6 के साथ मल्टीप्लाई कर दो। तो 6 इंटू पोटेंशियल ड्यू टू सिंगल चार्ज विल बी के क्यू डिवाइडेड बाई आर। क्लियर? तो इट विल बी 6 इंटू के का वैल्यू है 9 इंटू 10⁻9 और क्यू का वैल्यू है 4 माइक्रोकुलम, दैट इज 4 इंटू 10⁻⁻6 डिवाइडेड बाई डिस्टेंस। डिस्टेंस यहाँ पे कितना है, 8 सेंटीमीटर। क्लियर? हर एक चार्ज से डिस्टेंस कितना है, 8 सेंटीमीटर, दैट मीन्स 8 इंटू 10⁻²। So finally if we do the calculations, so how much we'll be getting? So 6 6 6 6 6 means here 4 2 ja 8, 2 3 ja 6, so 9 3 ja 27, 27 into 10⁻², ऊपर जाएगा तो 10⁻², so 10⁻11, 10⁻11 minus 6, so 27 into 10⁵. Clear? 27 into 10⁵, or we can write 2.7 into 10⁶ volt. So net potential at that particular location will be 2.7 into 10⁶ volt. So option A will be the correct one. Clear? तो बाकी में थोड़ा चेंज अलग है, तो ऑप्शन ए यहाँ पे सही होगा।